Hello everyone, and welcome to the GCAN webinar series. We are pleased to have you join us for the Gulf of Mexico Coastal Acidification Network's recurring webinar series that's presented by GCAN, the Gulf of Mexico Coastal Observing System, or GCOOS, the NOAA Ocean Acidification Program, or NOAA OAP. And the goal of today's GCAN webinar is to provide relevant information and resources about ocean and coastal acidification that's occurring in the Gulf of Mexico to stakeholders in the region from around the country. Our vision is a Gulf of Mexico that is resilient and prepared to address and adapt to ocean and coastal acidification. My name is Michael Aquafreda, and I'm the Knaus Fellow working with the NOAA Ocean Acidification Program, and I'll be moderating today's session. Thank you all for being here. And we're excited to have about 30 registrants from all over the United States. During the presentation, all participants are in listen-only mode. You are welcome to type any questions into the question box in the bottom of the control panels on the right-hand side of your screen. We'll be monitoring incoming questions and will pose them to our speaker at the end of the presentation. Additionally, we welcome your input on who you would like to hear from in future GCAN webinars, as well as what topics or resources you would like GCAN webinars to cover. If you have any ideas, please type them into the questions box and we will take them into consideration as we plan for future presentations. Today's webinar is being recorded and will be available through the GCAN website. The title of today's presentation is Forging Classroom Inclusivity Through Educational Research, Lessons Learned from the EDU-STEM Network. I'm very pleased to introduce today's speaker, Dr. Sophie J. McCoy. Dr. McCoy is an assistant professor at Florida State University's Department of Biological Sciences and works at FSU's Coastal and Marine Laboratory. Sophie McCoy is an ecophysiologist who studies impacts of environmental change in nearshore marine communities. She earned her PhD from the University of Chicago in 2014 and came to Florida State University in 2016 after completing a Marie Curie Fellowship at the Plymouth Marine Laboratory. At this time, I'd like to pass it over to Dr. Sophie McCoy.
Thank you so much. Thank you, Michael, for that lovely intro and for inviting me to talk about actually a totally new and different topic for me. This is the first time I'm talking about my work in educational research. And yeah, I'm really excited that there's an audience and willingness to learn about this. As you'll see from my talk, this is very much lessons that I'm currently learning and that we're working on at the moment, really active research, and there are also ways for you all to get involved if you'd like to. So because this is sort of an unusual talk for me, I thought and potentially for the rest of you as well, I thought I'd start with an outline. So very briefly, I'm going to introduce myself and what I usually study, and talk a little bit about why I wanted to start studying classroom inclusivity and how to loop that into how I really think of my normal researcher identity, if you want to call it that. And then spend most of the time talking about why diversity is good for research, and the EDU-STEM project, which researches classroom styles that either create or alleviate barriers to diversity and inclusivity. All right, so as you probably read when you signed up for this webinar, consider myself to be an ecophysiologist, so that includes functional ecology. I think about things like cryptic diversity, so diversity that is hidden from the naked eye, and consequences of climate change, and more recently, how to apply these different themes towards conservation and some management. A lot of my work involves algae, so you see me here in my happy place. This is a beach covered in large macroalgae, and parting it to see what's growing underneath and assess the diversity of that second tier canopy. And so in my lab, we focus on the linkages between the environment, physiology, and ecology. And physiology is really used as a lens to focus in on forcings that are coming up from the environment, that will ultimately influence ecology, but sort of through how that's experienced by different organisms. So the questions that I typically focus on include how do environmental changes affect the functions of marine and aquatic communities? What are the emerging roles of functional diversity? So back to my seaweed community, right? Which ones are contributing to the processing of chemicals, of energy, food production in different ways? And then how do those biological feedbacks go back into the environment and affect how different species interact with each other and how they influence the environment? Okay, so that's the type of thing that I typically think about in my regular research program. Okay, and as a part of that, I do some lab work and I do a lot of field work. And so there are a lot of opportunities for me to engage with students of different ages, different career stages in these various activities. Okay, so how does educational research fit into all of that? As many of you know, there are a lot of mentorship programs that focus on these early educational stages. And I participated in a number of those myself. So I participated in mentorship programs, often geared towards middle school students. There's this really great program called Spark that they have in Chicago and New York City, and I think expanding into a number of other larger metropolitan areas, where they pair up promising middle school students, but who maybe need a little bit more motivation to visualize themselves in their future dream career. Let's say maybe they really want to be a baker, to realize that, oh, hey, actually, when I'm cooking, I use science. When I want to explain what I'm cooking to other people, I use my English skills, my grammar skills, my maybe theater, visual communication skills to sort of show students, right, how well-roundedness contributes to taking steps towards that dream career that they might have trouble seeing that connectivity in that path that they want to take. There's also a lot of mentorship programs for high school students that I'm sure many of us participate in as well, bringing high school students in maybe for summer programs or for other sort of short-term projects and mentorship. And I think this is really common when you might be reviewing grants for the National Science Foundation or NOAA, and it's really common to see engagement in K through 12 outreach as broader impacts that many of us participate in. Yet, despite this, right, we're trying to get people into what we call the STEM pipeline. But it turns out that pipeline is really leaky. So getting people into the pipe is definitely an issue and something that we want to focus on. But we need to think about the rest of the plumbing as well. Right? So the US faces a shortfall in the total number of people earning STEM degrees. This is compared with other countries. And at every single major transition, so between educational periods, so K through 12 into college, but also college into grad school, and then from grad school into careers, and going up through the career hierarchy. At each of those steps, we lose members of underrepresented groups, specifically in STEM careers. Right? And so that's including a variety of different groups that people talk about. It could be women, it could be racial minorities, etc. And so given that we know all of that, and that many of us here in this seminar might be research university faculty, right? Why are we focusing our efforts on pipeline issues where we're not specialists, right? So if we spend most of our time in the classroom, I guess why don't we spend a lot of our time trying to contain the leaking that's happening in and out of our own purview? So before I get too much into that, I want to talk about just in general why diversity is good for our research and why we want to retain diverse members of the workforce through these various career stages, other than just believing that it's the right thing to do. this is actually a really good thing for us to get results. Okay, so this is a recent study. It actually just came out in May in Proceedings of the National Academy of Science. And this group is, they used machine learning to assess sort of records of science between 1977 and 2015. And so this includes records from the ProQuest dissertation database, right? So when you write your PhD dissertation, now these things get published online through this ProQuest service. And they also have digitized versions of previous dissertations. All of these dissertations include metadata, so student names, their advisors, institutions, abstracts that contain keywords, etc. And so they combine this with US Census data and Social Security Administration data to get demographic information about the students submitting these dissertations. And then they cross-referenced with Web of Science to see what publications from these same authors. So to clarify, they're not looking at citations of the dissertation itself, because in modern day especially, people don't cite dissertations as much as they would cite the individual chapters that get published as manuscripts independently of that. And so what they're doing is tracking citations of that person who wrote the dissertation. Okay. And then they're weighing this out by the number of PhD recipients at each distinct university to look at the demographic breakdown that you would expect versus that we have. Okay, and next they used machine learning to measure metrics of what they're calling innovation. And so I'm going to show a diagram of this next, but just to go through it because it's a little bit confusing. They're looking for keywords in the thesis, in the abstract, and they're identifying when pairs of meaningful concepts, so that machine learning through text has pre-made algorithms that I'm not even going to try to explain to you or to myself, but that they can sort of take out of a sentence what the meaningful keywords are in those. And they're looking to make matches. So this diagram might help a little bit. And I'm not sure if you can see my mouse, but I'll use it just in case you can. So here I'm looking at, just as a starting example, this panel A, Lillian Bruch, whose name I probably mispronounced just now, studied HIV and was the first to make a link between HIV in humans and a disease that was known in monkeys. She did this in 1987. And so this machine learning software would have taken HIV and monkey as their two sort of subject keywords and looked at patterns of occurrences of this in abstracts from dissertations and in the literature pre-1987, which was when she made this contribution, and found that her link was the very first time that link was made. Since 1987, that's been used 47 times in the literature. So going through abstracts in Web of Science since her PhD dissertation, that's measuring, I guess, the impact of this novel link. And so this has happened here. There are just 6 representative examples where this has happened. For example, here in panel D, maybe more of an impact in the number of linkages that have happened since their initial contribution to the field. All right, so I spent a little bit of time on that because I found it a little bit confusing at first, and I think it matters in how we interpret their results. All right, so what they found was when they did this over hundreds of thousands of dissertations, so every dissertation in science in the United States over that really large period of time, they found that the more a student's gender or race is underrepresented within their field or subdiscipline, the more novelty they introduce in their thesis. And so here they're looking at the percent of same gender within a discipline. So usually In this case, they're looking at how many women are in the discipline, but in some fields, right, like nursing or education, you would be looking at the opposite trend. So in those cases, men are the minority gender, okay? And so you see that the ones who are introducing the most novelty here, so defined as number of new links, are where women or men, whatever that particular gender is the least represented in that discipline here, looking at the x-axis. Not surprisingly, right, the less, sorry, that's also happening with respect to race here in panel B. But it turns out that the less a student's gender and race are represented by their peers, so like the more unique and potentially the more novel their ideas are linked into that, the less the peer group is receptive to taking up that idea and incorporating it into the ongoing work of that discipline. All right, so why? So you talk about these two things called distal novelty versus impactful novelty. So distal novelty is what they measured in their algorithm with the links, right? And so you're making links between concepts that are traditionally considered really, really different. They're very distantly related from each other. And so that's, if I go back here, that's how they're measuring novelty on this axis here. But impactful novelty is what's measured when you look at, since their dissertation and they introduced this concept for the first time, how many citations of that work. So how many people are using it actively in their research. Okay. So it turns out that both of these kinds of novelty are important in terms of remaining active in research and in obtaining a faculty position 5 years later. And they're finding that overall, women will introduce more distal novelty than men, but that's not necessarily tied to impactful novelty. So here in this graph, I'm showing you that the least distal, so basically means they're taking smaller steps in making these links. Those are the steps that are most impactful. So initially, I was reading this with my skepticismo hat, right? And so I felt like there were some open questions here, right? So they're saying that contributions from underrepresented groups in research are taken up at lower rates by the scientific community. It's relatively easy to measure that first metric, the distal connectivity. How different are the two ideas that are being linked for the first time? But assessing what that means is really difficult. And a lot of the ways that we assess that could be conflated, right? So are incremental steps more impactful because they're just easier for people to understand or easier for them to incorporate into their current work? You know, maybe there's a lag time. You are presented with this really revolutionary idea. It doesn't fit into your current work. You're gonna have to wrap up those projects and start something totally new to jump on board with that. So maybe there's a lag period that's not being accounted for the way that they measured this. And, you know, the alternative explanation is that the research community is just dismissing either minority contributions as it directly, or they're dismissing distal contributions, saying, oh, that's a super crazy idea. I'm not going to buy into that, right? But these could be leading to a false trade-off between understanding the impact of our research and why that's happening. But the authors actually addressed that, right? And they found really strikingly that the correlation between distal and impactful novelty on career recognition does differ both by gender and by race, and that it does affect long-term career returns. So when they modeled this, holding both of those novelty metrics constant, gender and racial inequality still persisted in career outcomes, right? And so they found that the numerically underrepresented gender within a particular discipline, those researchers had 5% lower odds of becoming research faculty and 6% lower odds of staying in research at all. These disparities are even bigger when we compare among racial groups. So the numerically underrepresented races within a discipline have 25% reduced odds of going into research education as a career, and 10% lower odds of retaining at any activity in research over a 5-year period. All right, and to sort of tie that home, they found that at really low impacts of really low levels of impact novelty, gender doesn't influence the probability of sustaining either a faculty or a research career. So that is really the slopes of these lines. As you get more impactful, if you belong to an underrepresented group, that's more likely to be discounted. Right? And so that has really, really big implications when we think about the makeup of sort of the mature, older science community that might have the biggest mentorship influences on everything below us in the pipeline. And we've known for a long time that diversity of our research groups spurs creativity. This isn't just something we know about from science. There were big Forbes articles about this written in 2016 and 2019, right? So you know when the business community is getting in on it, that there's probably results that we're seeing there. And there's been a lot of research on this since the mid-1990s. And some of this is just common sense, right? You got people from different backgrounds, especially from what we've just learned, that people who come into a discipline with an outside point of view can use their different experiences and their different perspectives to contribute to that work from a different angle, right? So this is really tying in with this new study about research novelty. And when leadership values those differences and makes it known that those differences are valued, then everybody feels comfortable bringing up those ideas. So nobody is afraid that someone's going to say, well, that's a really crazy out there idea, let's not do it. They might instead say, that's a really crazy out there idea, no one's tried this before, and let's go for it, right? And so that's the type of thing that that can really make a difference to innovation and creativity in STEM, like in any other activity. So what are retainment barriers? I've sort of talked about this really distal endpoint, and I talked about the fact that we're doing maybe an okay job sort of addressing K through 12, or at least we're paying a lot of attention to it. But what happens in between those two endpoints? And so, you know, retainment in the field, this is going to depend on two things. It's going to depend on the perceptions of others, right? If you're a job applicant, if people value and perceive your contributions as novel and valuable, that's obviously going to help you get hired. But it's also going to depend on your own self-perception. Are you going to choose to stay in this environment and with these colleagues, or are you going to choose to leave? And so, you know, matriculation in graduate school as well as in college of students belonging to underrepresented groups and backgrounds is really important. And so I'm showing this on this slide as well, sort of a call to action that came out of AGU, the American Geophysical Union, virtual advocacy earlier this summer. This statistic that only 15% of PhDs in geoscience are awarded to people of color, right? And that's probably not due to attrition during graduate school. I actually don't have those statistics, but very few students who make it into their second year of a PhD program are going to graduate without a degree. So the question really is, how are we getting students to graduate as STEM majors as undergrads, and then attracting them to graduate school to matriculate in the graduate school? Sort of two focal areas that I think our demographic is really well equipped to address, right? That's a group of students that we work with quite a bit. And so we need to understand really what the retainment barriers are. And a lot of them involve self-perception of students, right? And so here I want to just pause and reflect on these three terms we're probably hearing a lot right now: diversity, equity, and inclusion. And how are they different, right? And what do they mean? So diversity, right, is describing, you know, you're going to take a survey of what's there, look at the landscape. Are there differences between the people in your group? Equity is, are you treating them the same way? And inclusion is really that part that brings in people's self-perceptions and feeling of belonging. Okay, so an example that, again, I've taken a few graphics from AGU Sharing Science because I think they've really done a thoughtful job putting together a lot of these resources that are available for use on their Sharing Science website. But the way they explain it is diversity is where everyone's invited to the party, right? But once you get everyone there, you want to make sure they all have a good time. So equity is everyone gets to put their favorite song on the playlist. And inclusion, you can sort of think about it as, well, everyone's sitting there listening to the music, but everyone not only has the opportunity to dance, but I would say feels comfortable getting up and dancing, okay? And so that's what I want to focus on for the remainder of the talk. And so there's this really neat program called the CAMINO program. That's my favorite example of this. It's at University of California, San Diego. They have this Center to Advance Mentored Inquiry-Based Opportunities in Ecology and Conservation. And based on the research out of this group and others, they're finding that participating in fieldwork builds your sense of belonging, right? And this is for a variety of ways. Is, you know, one, everyone's always talking about hands-on activity and active learning, and very active learning happening during fieldwork, but you're in a new environment with a group of people. It's like sleepaway camp a lot of the time, right? You end up making really good friends there and really close connections, and you develop a really unique sense of your own, you know, mental and physical limits that are really different than they can be addressed in a normal office environment. And so fieldwork in particular is really important, and that's something that, you know, we, the marine science community, really have to offer to undergraduate and graduate students. We do a ton of fieldwork. And so when you're thinking about building in your broader impacts plan, the next time you're turning in a grant, consider building in opportunities that will engage undergraduates, especially from underrepresented groups, in fieldwork, right? And sometimes that's really expensive. Those of you who are seagoing oceanographers, bringing somebody into a cruise maybe doesn't fit in with their school timing, maybe it's really expensive, there are limited berths, etc. But maybe consider talking to the scientific lead of the cruise about building in those opportunities, because they're really, really important. Those of us who do field work, that's maybe a little bit less restricted, but maybe we're diving, we're going out on boats, we're going out to beaches. You know, these are really impactful ways that we can contribute, and frankly, with relatively little effort beyond what we're doing already. But I'm going to talk about classroom environments because that's what I advertised, that's how I drew you in, and I want to introduce the EDU-STEM Network. Like, it's classroom time, everyone's sort of starting class. I don't know about you, we at FSU started class yesterday. And I'm really glad this webinar is not on Zoom. I don't know if anyone else suffered from the national Zoom outage yesterday, but you know, we're going to have a lot of classroom challenges, and I think as we redesign a lot of things, as we move online this semester, is a really good time to think about other small changes that you can make at the same time. So performance gaps, which are not the same as a gap in ability of students, just a gap in how they do numerically on exams and course grades between especially males and females and ethnic and racial groups, are really well established as challenges for STEM education. Right, this has been studied for quite some time, and there are a lot of ways to alleviate that again deal with feelings of inclusivity and self-perception. So here's an example. This is from the University of Minnesota, our network lead, and this is part of the research that inspired the EDU-STEM project. And so here we're looking at exam performance score relative to the mean. So a score of 0 means you got the average grade for the class. in the same exact class, the same instructor, same syllabus, same exams, right? Fall 2014, 2015, and 2016. And you can see in 2014 and 2016, the scores of men and women are distinctly different. Women are doing worse than men on these exams. In 2015, the only difference was that the instructor told the students before the exam that they could retake any of them if they were unsatisfied with their score. This is plotting the student exam scores from their first try of taking that exam. So we're not, introducing any variability because they got to take it like 8 times. And you can see that there's no difference here between the grades of the female and male students in this class. And so this is really telling you, like, this is an internal process that influences something called test anxiety that's often felt in females and in underrepresented racial and ethnic groups who feel like they have something to prove in their performance of an exam, right? And so that makes you get intensely more nervous. And as we all know, when we get really nervous, we tend not to do as good of a job as we would have done approaching with a clearer and calmer mind. Right, so these performance gaps are a pretty pervasive problem, but a lot less is known about how to deal with these barriers in inclusivity and participation in STEM in college students. One thing that we do know is that one size does not fit all with classroom interventions. So things that work in a small class size or at a community college or at a small private college, those same classroom techniques might not be suitable either for the learning environment or the student demographic that you have at a really different institution. But what does link everything together is that confidence is one of the main attributes that link your involvement eventually in research and your intent to pursue a career in science. So we need to pay attention to whether, what we're doing in class and the assignments we're giving, are these things helping our students feel more confident in their science ability, right? When they take our exam, does it make them feel that they're confident and competent scientists? Or are we, like, I'm thinking back to some of my engineering classes from sophomore year, are we thinking, geez, I don't even know why I came to the exam and I don't know why I'm here. And so this involves changing our practices as faculty and as educators. And we know that lasting change is something, it's complex and it requires a major investment of time. We as faculty members self-report, right, that we're reluctant to change all of our teaching practices. We have a lot of pulls on our time. We understand that there are better ways to teach, but for a variety of reasons, we're not making that jump, okay? And so, we're all here today. I'm here, I'm a new convert, and I'm here to show you that there are actually some really easy things that you can do to build into this over time. This doesn't mean you have to take the next 2 weeks solid out of your life to rebuild your syllabus or do anything like that. You can make really small changes this semester, next semester, and support inclusivity in your daily teaching. One thing that's also really motivating, right, is to treat your teaching like any other scholarly activity, right? So do you make and test hypotheses about your own teaching, about your students' learning, and present that as a research talk? So kind of like what I'm doing, right now today. So we're scientists, we're kind of data nerds, and so at least for me, things that I can see and explain in a graph, I get pretty excited about. And so, while we're doing this, we also need to keep in mind diversifying sort of the voices of educational research. So if it's all people who are like me, looking at a classroom and saying, well, this is what we should do to retain people who may or may not be at all like me, that's not really useful. So the EDU-STEM network intentionally involves participants from a bunch of different institutional types. So we have R1 institutions, we have historically Black, Hispanic colleges and universities, and we have minority serving institutions and community colleges. So we're trying to get a range for a feel of what all the different institutional types are within the US. And it's really important to include community colleges and minority serving institutions because they serve a large proportion of students who are seeking STEM degrees. They actually teach 40% of all US undergrads, right? But they're only involved in 3% of educational research publications. So there's clearly a wealth of information there that we are not accessing and using to the benefit of everyone. And historically Black colleges and universities, they educate only 3% of college students in the country, but they graduate 27% of African American students with bachelor's degrees in STEM, and most African American student PhDs. So they have a really drastic and disproportional effect on the diversity in our STEM career field. And nearly 70% of the graduates are women. Right, so what are they doing that's promoting student success that, again, we can learn from at all institutions to promote this? So this is what the EDU-STEM network looks like. So EDU-STEM stands for Equity and Diversity in Undergraduate STEM, and it's an NSF-funded research coordination network. So at the moment, these are the partner institutes, but we are led by Sophie Kottner, who's an associate professor at the University of Minnesota in the College of Biological Sciences. And she is a bona fide undergraduate education researcher, but sort of a late life convert from being what I'm going to call, with big air quotes here, a regular biologist. Okay? And so the EDU-STEM network has 4 goals, right? And I'm actually doing one of those right now. I'm trying to increase the number of faculty in the US who are familiar with barriers to inclusion in STEM and who can apply evidence-based techniques to try and counter those barriers in our classes. And also wanting to develop a community of faculty who can serve as leaders, either just within your own department or nationally in inclusive techniques for teaching and assessment. And what I'm going to talk about for the last part of this talk is sort of the differences that exist in the cultural climate for women and minorities in STEM disciplines. And then in the network, we're trying to study this as a function of geography, institution type, and cultural profiles of participating departments. All right, so there's some really easy pedagogical interventions that we can participate in. Right, so as we talked about already, involving students in hands-on scientific research really builds their confidence. Something else is, and this is very, very easy for you to do, you could even do it today, changing the stakes of exams. So that means the percentage of the final grade that depends on a single exam is what makes it a low or a high stake exam. And that threshold seems to be 40%, okay? And so in this plot, we're looking at, again, the Z-score is the deviation from the mean of a student's grade on the exam. Women are in the triangles and men are in the darker squares. And we see low stakes exams, we don't see a difference in each of these cases between grades between men and women. So these are 3 different biology classes that were held at the University of Minnesota. And because there are a lot of educational researchers there and they have a really big biology department, they had different instructors in their classes change the proportion of exactly the same exams, but change how much that particular exam affected the student's final grade. And so in every case, in these 3 different levels of biology, when the exams were high stakes, they saw that women underperformed relative to men and relative to the mean on those exams. Great. So if you've got any exams this semester that are worth 40% or more of the total course grade, I I suggest that you go back and look at your syllabus and see if you can bring that down, even down to 35%, and that might make a really big difference. And I'll note here that we're talking about sort of binary gender. There's been very little to no research done on other sort of gender and sexual identities and effects of anything in the classroom. And there's been some but less research done on the effects of exam stakes and minorities in the classroom. But that's something that very likely follows a similar trend. Okay. And so other interventions focus on sort of social context of the academic environment, arguing for sort of small group activities, small group projects, because belongingness is going to affect not just if a student is confident in class, if they're going to raise their hand in class, but if they feel comfortable reaching out to their peers outside of class. You know, I can't tell you how many times a study group made a really big difference in my success in a class. And if you don't have that kind of network, if you don't feel confident reaching out to your peers to participate in a study group, that could have really big effects for your classroom outcome. There's something else that we already know, is that textbooks should showcase diverse role models. So we currently have actually a really good representation of males versus females relative to expected number of examples in textbooks. So here in the purple, the solid line is showing how many male scientists are used in a textbook example, and in the orange is female. And the dashed line is what we would expect based on what percentage of each gender earned a biology degree out of our STEM workforce. And so we see that by gender, that tracks really, really well. And I'm really pleasantly surprised to give us kudos there. Where we do not the best job is with racial diversity. So here we're seeing exactly the same graphs. In panel A, we're just looking at men versus women. In panel B, right under that, we've added in these little gray and yellow lines you can barely see that show everybody else. So white men and white women are in the purple and the orange. And then when we go to the other column, we see first the same graph, but we've taken out that purple white male line so we can zoom in on everyone else. And we see that we're making progress, so that's good. But when we take the white female line out, we can zoom in even more. And we see that while we're increasing the representation of most other groups, definitely in the last few decades, we still have a lot of work to do here in representing Asian, Hispanic, Black men and women in our textbooks, right? And so we all know, we've heard, you want mentors who look like you so that you can visualize yourself progressing in that career. Okay, so what can we do about this? Most of us don't write textbooks, but we can replace examples in our lectures and assignments, sort of keep pace with the field and bring in that greater role model diversity, right? So here's something easy. Every year, hopefully you're updating the examples you use in class with some stuff that's up to date, right? So not all of your examples reflect the literature that was there the first time you taught this class ever. And I know we're all guilty of this to some extent because it's really hard. You found a great example, you've built maybe a whole day's curriculum around it. But each year, I'll suggest that you try and replace at least one of the examples that you use in your lectures or in your homework assignments with something that's recent from the last year and that's led by scientists from an underrepresented group. Between now and 5 years from now, you will thank yourself because you're going to have all recent citations within the last 5 years, and you're going to have a really diverse network of full successful scientists that you're showcasing to your students. Something else you can do is to consider guest lectures or short videos to have students watch as assignments given by scientists from underrepresented groups. This is actually a perfect time to do that virtually, right? There is no excuse not to ask somebody to zoom into your class right now and do something virtually. You don't necessarily need a budget to do that. For early career scientists, that can be adding value to their CVs as well, so it's sort of a mutual benefit. Do keep in mind that some minority scientists could be overburdened with requests right now, either to do things like this or participate in other committees. Sorry. You can consider compensation to show that you are valuing their time and to make it worth their time. And this does, again, if your department doesn't have a budget for that, you can also volunteer to help them with their work, right? Maybe they would love to have a day off of teaching their class to focus on their research, and you can volunteer to give a guest lecture for them. So there are a lot of ways that you can do this without necessarily having a budget. All right, and I think this is my last example here, is that smaller class sizes are really important in reducing those performance gaps. So this is something we struggle with constantly across the board with university level education, especially in introductory courses. Where I went to school, we prided ourselves on having no more than 30 people per class, except, right, intro chemistry, intro bio, intro psychology, intro physics, everything that pre-meds have ever thought about taking. These are big investments for universities. And a lot of times it's related to the size of your program, the major, and the financial investment in faculty and in building space. And so, you know, a lot of times you hear about this practice weeding students out of introductory courses. This is something everybody, even the people who advertise it, know that they should avoid, but many faculty see it as necessary so that you don't have students both, you know, for the good of themselves and for the good of the rest of the class who aren't ready for those harder courses. What we should really be doing is, right, trying to make sure everyone is ready for those harder courses. But obviously it's really hard to do, especially when those initial classes we're exposing students to are so big. So it turns out that as class size increases from 40 students to 250 students, in this study they only studied gender, but women performed increasingly worse on exams and overall in the course, right? So, you know, and here they're not, it's not standard, so it's not exactly the same course, it's not exactly the same instructor, but they're pooling classes from 4 different universities of different types across the US. Okay, so what can you do? I know I have no control over the class sizes of the classes that I'm assigned. I have very little control, I should say. I have one class I can choose to cap at 35 or at 50, right? But there are things that you can do, like you can create subgroups through activities. Again, that also contributes to some of the other goals that we talked about. Small group projects, and you can engage with students in discussion sections. But don't be afraid to lobby above your pay grade, right? Lobby your department chair, lobby them to lobby your dean. Smaller classes are good for everybody. Instructors get lower course evaluations by students in big classes, and that's because there are fewer opportunities for you to interact directly with students and for you to know exactly what level they're operating at and to offer that challenge for them, okay? So if you're not motivated by anything else, or if your colleagues aren't, at least at FSU, our merit raises depend on student evaluations to some extent, and that's probably the case for a lot of other faculty as well. Okay, so what are we doing in EDU-STEM right now? And I know it's 2:50, so don't worry, I'm wrapping up here. So we're doing surveys across the different participating institutions and courses. We administer them at the start and the end of a semester or trimester. We just finished our first year of the Research Coordination Network, so we're analyzing data from fall 2018 and fall 2019. At FSU, my colleague Kevin Dixon and I have actually started asking our own questions using the exact same surveys that we administer primarily in the intro courses for the EDU-STEM project. But we're asking, but we basically have these, a lot of small lab classes that we offer at FSU that, based on everything I've just explained, we think should be ideal classes for inclusivity. But are they, right? And so that's what we're trying to find out. And so we actually just got our institutional review permission to continue this research approved yesterday. And so we're focusing now on analyzing that data, student survey responses paired with their course grades to find out. And very quickly, I'm going to just flip through the survey questions because I think people might be curious, right? So questions like, presently, I'm confident that I can discuss scientific concepts with my friends or family, present scientific results orally. I prefer classes that are challenging. I like what I'm learning in this course, statements like that. We're assessing classroom experiences. I think my instructor and my peers judge me based on my ethnicity or my gender, statements like that. Gauging how committed students are to continuing a career in science, what extracurricular obligations they have. So are students engaged? Are they working full-time trying to get their degree? Things like that can really affect their grade and their sense of networking with their peers. And thinking about academic belongingness and their interactions with their faculty members. And the last part is just gathering demographic information. All right, so one, I promised this was not just a giant ploy to get you to join the EDU-STEM network, but if you're in a biology department, please consider joining the EDU-STEM network, especially if you're in this highlighted portion of the country. We're looking for regional patterns, and we don't have anybody from, I would say, the middle half of the country, right? The obligations are fairly minimal, so you obtain institutional review board permission for human subjects research. Everyone in the network is happy to give you examples of our applications for institutional review board. These are pretty nationally consistent because they're set by a lot of things that the NIH has jurisdiction over. And so it's very easy to amend somebody's proposal for, say, from FSU to your own institution. I would say it would take half a day of work in the first year, followed by a few hours here and there throughout the year. Solicit instructors to participate. So will they send you their class email list? And then at the end of the semester, will they send you the grades, basically highlight a few columns from their grade book and send it to you. You get the survey into Qualtrics, which is an online survey tool, and you email it to students. And then you concatenate their survey data, which Qualtrics has already put into a CSV file, and then combine that with course grades. So if you're interested in joining the network, totally do that. There's a link for how to do that online. And last, you know, we're trying to better understand education in marine science, and really we don't know what marine science education looks like. It's a very multidisciplinary topic, and you could see, right, a physical or chemical oceanography being taught and approached a lot more like chemistry or orgo than maybe something like biology. And before we even have a handle on the diversity of teaching approaches and pedagogy within marine science, to then start studying student behavior, the very first thing we're going to do is set up a faculty survey. So if you want to be involved in planning that or on the analysis side, please email me. And if you don't, maybe watch your email this fall, you'll probably be getting a survey from us. So please think of me, and please take it and encourage your colleagues to do that too. So I appreciate all of you for being here today. And I'm really eager, especially to answer questions. So I'm going to pull the chat up. You might see something a little bit funny going on now with my screen, but I can only see one window at a time. Cool.
Hi, Sophie.
Hi, Sophie.
Hi.
Thank you so much for a great presentation. If you'd like, I could help moderate with the questions.
That would be fantastic. Thank you.
So the first question I see is from Morgan, and it is the 40% for all exams overall or for any individual exam?
It's a great question. It's for any individual exam. So typically it's the final, right, that we might have worth 40% or more. Yeah, that's a really great question. And I think obviously that's common in biology because they had data from only 4 institutions to do that, but I think that's even more common like chemistry and physics.
Great, thank you. I actually had a question for you. So you talked
Yeah.
a little bit about the importance of confidence,
Yes.
but and I totally understand that. But thinking back to the very early parts of your presentation where you talked about how women and people of color might be more distally novel in their dissertations, yet still have worse outcomes if they want to get a faculty job or a research job. To me, that sounds like the most discouraging thing I could hear. How do you how does someone build confidence if the data shows that they should be discouraged by the outcomes?
Yeah, that's a great question. I guess there are two ways to think about it. And one, and I guess this first way is directed at those of us we're already here, right? And so that means that we've jumped through some pretty big flaming hoops. And so we should be super confident because once you've gotten into grad school as an underrepresented student, you really should be confident that you belong there and that people think you belong there. And that should give you confidence and conviction in your ideas. And I actually think that is what in part, and you know, this isn't scientific, this is just sort of my own observations. Now on the other side, as a faculty member, I think that having worked that hard and having known you've worked that hard does build your confidence once you get there. And of course, that's not really what I was talking about today. And so I think that role really does fall on faculty members. You really want to encourage those students, and you want to be aware that clearly there's a bias here. And there's other research that shows that both female and male faculty members in STEM inadvertently favor male students and rate their performance higher, which is super alarming, right? Because you would think, you know, there's this perception that you're going to take care of your own, and that's clearly not true statistically. And so I think that we need to make sure that we are looking out for those students and are aware of these biases that we probably don't think we have. I'm certain now, the more I read and the more I think about things, I realize things about myself and my own teaching that would have never occurred to me. You know, I would have considered myself as not the person who needs to be paying attention to this seminar, but I very much do need to pay attention to this, and I think we all do.
I agree. I think we all do. So a couple more questions came in. The first one is from Matt Whalen. What other small things are you thinking of doing this term to improve inclusivity in online courses? I think a lot of people are probably thinking this online component that we're in now, how do things change?
Yeah, online is both a blessing and a curse, right? And so it's a blessing in that we've had to change things. Like we were forced to change some of the things we were doing. And I actually think it's encouraging more people to take what we call a flipped classroom design. So that's when you have FaceTime be more discussion focused, and then you flip the lectures into homework. And so some people are pre-recording their lectures, and actually there's also been a push, at least from our teaching community at FSU, we've been asked if we can to offer courses asynchronously, because some students are at home and they might not have the bandwidth to log in at exactly during class time, because maybe their mom or dad is on a conference call right now, or maybe they have 4 siblings who are at home who are also teaching or learning online. And so if they're available to watch a video of your lecture at any time and then still be able to engage in the class, like maybe through some kind of online chat room, a lot of like Canvas and Blackboard maybe facilitate things like that, that a lot of universities use. And then using that class time or a chat function for small group discussions with students, and maybe, you know, encouraging them to do some smaller projects. I had some success this spring using polls and breakout rooms. So you can pre-assign students into breakout rooms of whatever size you want. And then I haven't actually mastered this yet, but there is a way for you, the instructor, to float, spend 5 to 10 minutes in each of those breakout rooms talking with students about their project or about the answers to whatever question you assigned them. And that gives you some more face time in a smaller group, and helps them to feel it. Really, you think that you want to get to know them, but in reality, you want them to feel like they're getting to know you equally or even more so.
Those are some great tips. Thank you. So we have what looks like one more question, or actually another one might have just popped in. Oh no, that's Mark saying, or Matt saying, thank you, great stuff.
Yeah,
one more question from Giselle. Does the proportion of women to men or non-underrepresented minorities to underrepresented minorities affect the difference in performance on high-stakes exams?
That's a great question, and that the best answer I can give you right now is that we think so. That's actually something that we're looking at in the current data that we have from 2018 and 2019 from the EDU-STEM project. Yeah, so how I see that question as asking how isolated are you and how does that affect it?
Right.
And if you think back to that very first slide or very first study about like innovation and novelty, we saw from that study that people like women in computer science versus women in nursing or women in biology, where we're sort of at 50-50, along that gradient really changed the amount of novelty that you produced. And so I feel like that's a reflection of the same issue.
Absolutely.
But yeah, that's a great question.
All right, at this time, I don't see any more questions, and we're a little bit over our time limit. So I think at this point, I'm going to thank everyone for attending the GCAN webinar today. We welcome any feedback, further questions, or suggestions for topics for future GCAN webinar series. And I want to thank our speaker, Dr. Sophie McCoy, one last time. This was an excellent presentation. I'm excited to share the recording with a bunch of faculty members I know very soon. Thank you very much. Have a great day.